both of today's examples on the surface may look a little simple, but I will say that there's some really valuable tech tips in here that are really nice that I wanted to bring them up for. So don't let the complexity of the part throw you off here. There's some really good ones. So for this first automotive example, it's a smaller object and it's scanned with maybe something along the lines of this device or this device here, or this one right here, where they set a small sheet metal object down and scanned it that way. So if we go ahead and progress over here, so this is a sheet metal stamping. And whenever the sheet metal or stamping application comes up, this is the way I usually steer people on how to reverse engineer it. And I wanted to highlight this one and how we go about reverse engineering a sheet metal part. And the idea here is if we reverse engineer it as a constant thickness part, then you can load this into the CAD software that you're working with, and they actually have a sheet metal applications that will then flatten it out and flatten out all the bends and for you. So that is the approach that we take with those types of applications. We reverse engineer them as the 3D part because of the way our tools in our software work. It is the best for us to do it that way. And again, look at this part, looks a little simple, but you'll see here as I roll back through the history tree that it has a little more to it. So I'm going to go ahead and just toggle over to Design X. We'll just give it a second to pop up on your screen. And you see here, I actually have Design X open, and I have the final product loaded up with the scan data in here. And as usual, I always bring up that Design X is a history-based CAD modeler. And I love the debate, and I love when CAD guys go through and they talk about direct modeling versus history-based modeling and all of that. And I love entertaining those ideas of the advantages of both. But one huge advantage of the history-based application here is that somebody modeled this inside of Design X, and we have the entire history, so we can roll back to the beginning, and we can step by step go through the tree and see how somebody modeled this and kind of reverse engineer their reverse engineering application. It's a very meta type thing here we got going on. But so what we're going to do is just kind of go through the history tree and look at how this person reverse engineered this part. So we'll go ahead and roll forward here. There's the scan data. And here, let me pause and show my screen real quick, because sometimes this, there we go. Sometimes this happens with GoToWebinar. I get this flash on my screen, and then what you guys probably saw is it like scaled my screen way down. So I'll try to keep an eye on that. It's something that tends to happen for some reason with GoToWebinar. I will get back to it now. So here we go. We will go ahead and roll forward a couple steps. You see here, we roll forward, and there it is. We went ahead and fit a surface plane on this area here. And there's a whole host of ways that you can do this. In our software, we have the ability to fit surface primitives by selecting an area of the mesh and say, fit this. You can fit it as that, or you could say, I want to fit that as an extrusion as well, and it will fit a surface extrude through that geometry. So if I turn on regions here, just to show that, like, I can just click on a flat plane. We'll just do this one right here. No, that one is not. We'll just select this one here. Again, if I come over to fit surface primitive, you see here I can fit these different primitive shapes and give it an extension value. Say I want to insert this into the tree, hit next, and you see there we go. It's going to create another one for me. So I'll just back out of that so I don't mess up any of my history. And we will take a step forward here. So we're going to go ahead and then fit the vertical and the horizontal there. And you see the next step is they go ahead and trim those two together, and then they fillet those together, fitting to the mesh. Now, one thing that's interesting about the fillet, I'm just going to go in it here. You'll notice that when you're using Design X, just as a little tip here, some people that are newer, there is this estimate radius from mesh. So when you're in the fillet tool, you can hit that. You'll see it was 6.6, but now it went and looked at the mesh and it said, hey, I think it might be 6.182, whatever. So we can use that estimate and then override it and make it whatever you want it to be. So that is a really neat little application there. And that's another example of where all throughout the modeling tools, we have these touch points where it can actually reference the mesh or the scan data and pull information from it that help you model faster. So we'll go ahead and step forward a couple more steps here. We're on the bottom. You'll notice that those regions, as I rolled over before, that those are considered a cylindrical region. So we went ahead and we modeled that, and you can use the extrusion wizard to do that, and it will create an extruded surface, and it gives you the history, so you can come over to the sketch as well, and then you can go normal too, and you can redraw that. If I turn my mesh off, I'm just going to hit delete here. So whatever way they did that, they must not have used a mesh sketch to do it. So you can go in and edit that sketch, though. That was what I was trying to show there anyway, is the ability to go in and edit that sketch if I were going to make a change on that diameter. And then I can come back and say I want to trim that to it. And it looks like they didn't go ahead and fillet that yet. They wanted to go ahead and model this cylindrical area first. So then it looks like they went ahead and modeled that other side, trimmed it to the other side, and then they filleted both sides here. So you see where we're going here. We went ahead and modeled the center here of the sheet metal part, and then now we'll go ahead and use some other tools to start trimming areas away. So what they do here is they'll come over and let's go ahead and turn the scan data off there. Model that center extrusion and trim that in, and then fillet that with the surrounding area. And then now they'll go ahead and trim the slot away. So they cut that hole in there. And then looks like now what they did is from this direction, they went ahead and fit an extruded surface and trimmed those areas here. Now, for this type of direction, some people may ask, well, how did they come up with that? You can turn off the surfaces, and there's a whole host of different ways you can do this, but you can select all these regions. This is one way of doing it. I can actually select a bunch of regions and holding shift here. And if I want to, I can come over to vector, and I can say calculate an extrusion axis from this geometry, right? So I could say calculate, remove outliers, hit OK, and it will create an extrusion axis. That is one way to do it. Now, if it happens to coincide with the direction of this plane, you can just click on that plane, create a sketch, silhouette the entire part in that direction, and it will allow you to create that, which it looks like it might align with that flat plane. So if I were going to silhouette and trim this whole part in one, like you can see it's multiple axes there. So we don't necessarily need to do it on this part, but I want to point out another piece of functionality here. If I come over to Mesh Sketch, I can silhouette the entire part. So we'll go ahead and turn off these. and you can see how you can silhouette the entire shape of that part. Come in and create a sketch. And then you'll notice that this will help you determine, you know, that the entire part is not in the same axis. But what I wanted to bring out is you can use the silhouette just for this area and sketch all the way around here and create, just like they did, the surface trim for this area alone by sketching all of this by coming in and using all these tools here, like so. So you can see that all of the sketching tools will fit directly to the silhouette geometry there. By the way, the slot is really neat here, by the way. I can select that slot and look at it best fits a slot for me. Now, if I need to make any changes about it, I can throw dimensions on it. So if I wanted to make it a different diameter, I could come in and throw a center line on it and constrain that center line. And then come in, and if I wanted it to be horizontal, make the midpoint dimension, anything about it I can. But I just wanted to point that out, that all of these tools will best fit to the scan data that's here, this polyline. So I'm going to go ahead and just exit out of that and discard all of it. But just to show you what's available there. So now I'll just find my spot in the history tree, and they went ahead and trimmed that area away. They cut from this direction, trim that area away, and you can kind of see what we're doing. We're just going to create a zero thickness surface that references or creates the top surface of this part. And there are advantages to doing this, because you can just trim the top and create that zero thickness surface and then thicken it here at the end. So you can see here, trimming all these different areas off to make them exactly what we see it to be in the scan data. Cut this hole, trim it away. This one. Cut these edges, trim it away. And then it looks like they went ahead and I think the reason why they did this is, no, it does look like that is perpendicular to this, but they went ahead and thickened it before they trimmed that end piece. And it could just be that the way it thickened, it didn't thicken the way they wanted to, so they went ahead and did it and then trimmed it. And it does look like the way they trimmed it wasn't perpendicular, again, to that cylinder there. Then come back and add all of your dress fillets and things like that. So they filleted everything. And then, as usual, you can come over and check the deviation of everything that you've modeled to see how close it is. And another thing to point out is, as I roll my mouse over the surface, it'll tell me the deviation in that specific area to see how close it fits. And since it is a stamped out part, you're going to see some more deviation on this side because we made it a constant thickness.